Yeah, we talk about the gravitinous interactions and the cosmologies in the supersymmetry. The gravitinous appears as a superparticulars of the graviton, and from the spontaneous symmetry breaking of the supersymmetry, this provides the Goldstino as a massless fermions for the broken order generator. But such a Goldstinos are eaten by the gravitino, like as the goldstones are eaten by the WZ boson, and the Goldstino becomes the longitudinal motion of the gravitino. The gravitino interaction can be obtained from the supercurrent. For the solid transformations, the spin-off fields the transforms with the scalar field, and by using that we can obtain the supercurrent with the Noether's theorem. So that this is changes the Lagrangian over the partial mu x is some field, and this is the changes of the field. So this gives the the solid transformation of the spinor gives this term, and the solid transformations of the Gaugino gives the gauge boson sum, and this is the Lagrangians change of the Lagrangians over the partial mu days now, and also similarly for the solid transformation of the gravitino, this gives the up term. And the supercurrents are conserved. So by using the conservation equations, we can obtain the interactions Lagrangian for the gravitino. And so this is gravitino, and this is the supercurrent except the gravitino path. So this is the small j mu, and 1 over the up from the distance. So the interactions of the gravitinos are suppressed by the 1 over up. So the interacting Lagrangian of the gravitinos can be written by such a form. So the all dimensions were consistent. This is M4, M3 over 2, M1, M1, and this is M1, M2 over 2, and this is 1 over the M square. So M1, M2, M3, and M6. This gives M4 also for this term. This is M2. This is 3 over 2. So such a 1 over the f suppressions can be replaced by the gravitino mass by using this formula, and this is the Bioman-Vertax for the gravitino and the scalar fermion, gravitino, gauge, and gauge boson. By using that, we can obtain the decay light of the slip particle to the gravitino. By using the dimensional analysis, there is the f scale from the coupling term, and the m by power, and the space factor. For the gravity mediations, to give the electroweak scale of soft mass, the surge breaking scale root up is 10 to the 10 CV, relatively large root up, and the mass scale of the gravitinos is comparable to the soft mass scale. So this is the 100 GB, and the gravitino might not be in this case. But the gauge mediation case, this soft mass is still the bit to the electroweak scale, so the root up is small, and the gravitino has a pure electron ball scale, so this can be the RSP. For the gravity mediations, the root up is very large. It means that the interaction is small, so the decays occurs outside of the detector. But in the gauge mediations, the root up is small. This makes the large interaction, and the decay occurs quickly. This makes the gravitinous overabundance in the cosmological point of view. This is called the gravitino problem, and phenomenologically, there will be the missing energies in the collider. So here are some of the detailed analysis for the gravitino mediation. The gravitino scale is the 100 GB to the 1 TB, may not be LSP. and due to the large root up, the interaction is small. This makes the decays of the gravitinos across the light. So the gravitinos decay to the other particle. And such a light decays of the gravitinos in the early universe might interrupt the BBM. So to avoid the BBM interruptions, the reheating temperature has upper bound, which is 10 to the 10 ZB, to make a small productions of the gravitino, but this is weird. This requires a low temperature biogenesis mechanism. For the gauge mediation supersymmetric rankings, the surface mass scales are still electroweak scale, but the gravitino's mass is a pure electron volt, which becomes RSP. And from the relatively small root up with the 10 to the 4 ZB, the interaction strength is large due to the one of the suppression, and this makes the gravitino decay to the past. Some particle decay to the gravitino because this is RSP, so this makes the overabundance problem. Similarly, to avoid such overabundance problem, we can give the upper bounds of the reheating temperature depending on the gravitino mass. So, for instance, if the gravitino mass is electron volt to the GeV, NRSP is the particles that decay to the gravitino, NRSP, and 2 makes the gravitino abundance is smaller than the 1 to be the dark matter's density. The reheating temperatures should be smaller than 10 to the 7 ZeV if the gravitino mass is rather than 100 kiloelectron volt. And if the gravitino mass carries 100 ZeV, so the TB already started, this may destroy the BBM. Gravitinos can decay to the light element, and to avoid the issue, we should suppress the gravitino productions, and the reheating temperature just has upper bound to the 10 to the 7 ZeV.